My name is Heather Shaffrey. I work at the K20 Center at the University of Oklahoma. And my role with the Grazing Cat Project has been to work with the K12 education community and sort of connect them to the content of what the grant is. And so just a little bit of background about myself. I have a master's in ecology and evolution. And after I completed that degree, I taught middle school science for a few years before joining K20 Center here at OU. And since then, I have also become a graduate student in the science education program, and I teach undergrads as an adjunct, doing pre-service science teacher education for elementary teachers. So the K20 Center, if you are not familiar with it, and most people outside of education are not, we are an education improvement center, essentially. We do a lot of innovation and leadership development for K-12, well, K-20 education, so through college, to help improve education as a system, in Oklahoma specifically, but in the greater education community through research and are being embedded in that. So we do a lot of, we are almost entirely grant funded, and we do a lot of leadership development. We engage with parents and students in the community to get students into and through college and empower them to handle their own education. And then teacher professional development, which is where I live, over in the STEM program. So let's get into it. So K12 Agricultural Education is generally restricted to the typical extension programs that you would expect to find it in. So FAA, 4-H, things like that. And science teachers and classroom teachers outside of agricultural education tend to see ag ed as an additional burden on the time that they're already stretched thin on in their classrooms. They don't necessarily see a clear connection to their own content, and in many cases, they don't actually value it in urban classrooms, either because they don't see the connection or they just don't think about it as being an important connection. And so part of tackling that is teacher professional development, in addition to the fact that teachers who don't have an agriculture background and don't see the value in it are going to be unprepared to teach it. They're also embedded in this science education context, which is driven by the next generation science standards. Those standards have really created a change in classroom instruction. The standards themselves and the assessment of them are really cognitively demanding of students, and they essentially ask them to coordinate practice and content, and then sort of overarching scientific ideas and lenses that cross-cut all fields of science. And the integration of all of these ideas, while pretty intuitive, is a significant change in the way that teachers teach. And so we really need to provide professional development around these research-based instructional practices, in addition to preparing teachers to teach agriculture. And so we accomplish that through authentic research experiences for teachers, which I will refer to as ARET. ARET's essentially pair practicing scientists with K-12 teachers. And the idea is that they're learning how to conduct authentic research. And there's sort of two models for this. A traditional one that you see in a lot of National Science Foundation grants are called ARETs. And those are going to be long-term, usually 6 to 8 weeks, often during the summer, where a teacher embeds themselves in a lab or a field research group and conducts either research in partnership with an ongoing project or develops their own and researches it over that time. Or there's a short-term experience, which is really what we do, and it's 4 to 5 days, and the emphasis is less on conducting the research itself and more on emphasizing the professional development aspect of that. So in addition to doing the research, how do you translate that into something for students that looks similar and helps them develop the same sort of research skills and understanding of what science really looks like in the wild? And so what this really accomplishes for teachers in many cases who don't have a science background, it helps them really understand the nature of science. So that science isn't all lab work in lab coats. Science isn't the scientific method where you go step by step every single time you do any kind of investigation. And it really opens up their opportunity to see science as it is across a variety of contexts. And so we conducted an authentic research experience focused on soil science for the last 2 years, and we'll be continuing into this coming summer in June. This particular program is actually funded by a different USDA grant, but we use the soil science ARET experience to develop lessons that are associated with grazing cap. And so while the lessons are the final product, I think the ARET is really the more important piece of what's going on, because this is the meat of how we're bringing agriculture into classrooms. And so our workshop model for this particular ARET is it's 4 days at the Blue Stem Agri-Learning Center in El Reno. Blue Stem shares property with historic Fort Reno and then also the USDA Grazing Lands Research Lab. And so we have several teachers stay on site if they have to travel more than 60 miles to get there. So they live in residence for those 4 days, and then everybody else commutes in daily. And this year and the previous year, we partnered with Dr. Breck Peterson, who works in affiliation with this grant at the GRL and then elsewhere. And we would spend half the day with Breck really learning research techniques, how research is conducted, how you analyze the data you've collected. Then the second half of the day, for all 4 days, they would spend with me working on pedagogical practices and developing curriculum and developing lessons to bring back into their classroom. So the research piece and then that classroom application piece, the professional development, sort of were interwoven throughout the entire 4-day sequence. And our emphasis was really content-wise, learning how to measure soil properties and understanding the interactions between soil and plants and organisms. And by organisms, I mean specifically the organisms that live in the soil, microbes in particular. And so as part of this, we connected soil science to those agricultural practices. The benefit of working at this GRL site at Blue Stem is that we were able to actually go out into fields that are under different management practices and compare the quality and the health and the characteristics of soil in each of those to help teachers really see the impacts of how agriculture is conducted, and then also tying those things to climate change and the role of soil and the role of agriculture in climate change. And then through that process, teachers create these classroom-ready lessons, and the goal is to emphasize soil science, agriculture, things that they learned during their 4-day ARET experience. And as part of that, we train them in research-based instruction, and we really emphasize the Oklahoma science standards. And those are essentially the next-gen science standards with some tweaks to make them more Oklahoma-friendly. And the goal of these for students is really to have students doing the kind of research, investigative classroom experiences that the teachers had in the field at the GRL lab. So our ARET participants over the last 2 years, we've had 27 middle and high school teachers, so grades 6 through 12, particularly environmental science and biology teachers in the high school level. They came from 16 different school districts, and they represent 13 counties across the entire state. I think you can all see the map. Each of those little bars represents a teacher, and every color is a different school district. And we've estimated that about 2,500 students are impacted by these teachers annually. So that includes the students in their classroom immediately following the ARET, and their students in the subsequent year, so years 1 and 2 teachers. And in addition to this, many of the teachers talk about how their fellow science educators sort of partner up with them, or they share the resources and the learning that they brought. And so additional students beyond that 2,500 estimate are also getting to get the positive experiences that the immediate students with these teachers are gaining as well. So as part of this project, we collect a lot of data, primarily survey-based. And so we give the teachers a pre-survey and a post-survey about the workshop, and we specifically focus on their beliefs and practices during this. So we ask them about their views on science education, their sense of their own science teaching self-efficacy, and the way that they teach. And then we ask them some content-based and some belief-based questions about soil science, agriculture, and agriculture in classrooms, and then also climate change. And on the right side of the screen is an example of 2 of those questions. So we give them a Likert scale, so from strongly disagree to strongly agree, and they select it for each of the prompts. So I enjoy teaching science, or agriculture is too outdated to be taught in school. And what we're looking to see, and it actually really varies depending on the question, we expect to see either they're demonstrating an increase, so they feel more strongly that they enjoy teaching science, or they feel that agriculture is not too outdated to be taught in school. Occasionally we see the opposite, when they start thinking retrospectively and go, oh, you know, maybe I wasn't teaching that as well as I thought. But the bottom line is we're able to see how much they change in their understanding. And so a little bit of data analysis. We were able to analyze it year by year so far. We haven't done the comparison of everybody from 2017 to 2018, but we did some paired t-tests and some non-parametric analyses depending on how the data looked. And having such small sample sizes, 16 teachers in 2017 and 11 in 2018, make for a little bit, some of the results that we would expect to be significant were not just based on our sample size. We don't have a lot of power. But that said, between their pre-ARET opinions and their post-ARET views and practices, we saw significant increases in the way that teachers think about and talk about agriculture, and how agriculture is conducted, and what agriculture looks like in their classrooms. And they also discuss seeing the importance of soil health, so how soil is related to their actual lives, and it's not just the dirt under their feet. And they also express a deeper understanding of what those biological processes look like, what those physical processes look like, being able to conceptualize the content piece of that, in addition to really valuing it as a piece of education. They also generally walk away with seeing a greater relevance and a greater importance of bringing agricultural science to their science classroom, and not leaving it relegated to 4-H or FAA, but also seeing it as really valuable for the urban students. Really being able to connect to what's happening in modern agriculture, where our food is coming from, what that looks like, and really having sort of this eye-opening experience of how important it is that students get this content. They also leave more comfortable with this idea of uncertainty, so not having a right answer, or not knowing how an investigation is going to turn out, or having a question change mid-investigation because something has come up that was unexpected. And a lot of times science teachers are very uncomfortable with that, particularly if they don't have a science background, because they feel like they need to be the expert with the answers in front of their classroom. And so one of the benefits coming out of the ARET is that they can walk into their classes and feel better about not knowing the answer, and saying to their students, you know what, let's figure that out, without feeling like they're failing as an educator. And it's really reinforcing for the students that, you know, they're sometimes being wrong in science is actually really helpful. And a lot of times there is no being wrong, because there are multiple ways to get to a result. Many of them who are not confident in their science backgrounds leave with a greater sense of their own strengths. So understanding that they actually do have the foundational skills to do science, and to do science well, and to understand it. Even high-level concepts that they maybe wouldn't have given themselves credit for. And then in terms of classroom practices, they all feel much stronger in their grasp of and use of both the Oklahoma standards for science, and then those research-based teaching practices that we're really trying to help teachers develop for science education. And they also see a really important sense of interacting with practicing scientists. So keeping abreast of what modern technology in science looks like, understanding how practices are changing over time. And a lot of them talk about how that's not something that they had ever thought about before, but now that they've experienced it, feel like it's really important, and they want to find other opportunities to do it outside of this little 4-day experience. So the real value of this, aside from changes in teacher understanding and belief, is what this looks like in the classroom. Because while we want teachers to be more confident and have more self-efficacy in what they're doing, the end goal is really to make sure that the students are getting something out of this, and they're walking away taking these experiences that their teachers have sort of translated. And so these teachers write lessons based on their experiences, and they really emphasize having the lessons driven by their own students' questions. So getting students to be curious and then investigating those things they're curious about. The lessons emphasize investigation, whether that's an experiment, whether that's going out and making observations, doing research. The goal is that students are collecting data of some kind, whether it's empirical or qualitative. And then they're requiring students to develop explanations, and specifically that they need to justify their explanations with evidence. In our current situation of sometimes not accurate science being put forth in public spaces, it becomes really, really important to make sure that students have the ability to leave a classroom and understand the value of evidence and be able to use evidence to back up the claims that they're making. And we also see as part of that, when students are able to justify their explanations with data, they tend to have a deeper understanding of the science that they're doing, because they actually have to think about it beyond their knee-jerk reactions or parroting something that they've been told or that they've read. And so from a practical standpoint, these lessons engage students with practices that are sound in education, but also practices that really mirror what scientists are doing in their own research in real time. And so what we've seen over the last 2 years are some pretty excellent agricultural connections, and in particular, some local agricultural connections. Quite a few of the teachers who travel long distance and stay in residence are the middle school science teacher, or they are the biology teacher. Sometimes there is one high school in the entire district. And so from these smaller communities, these teachers are able to take their experience and really capitalize on their local environment and their local agricultural connections. And for urban teachers, urban teachers are really focusing on how they can find those connections, and if they don't have any available, how they can make it clear to students and help students really dig in and see the value in agriculture in their own lives. And so some of the really excellent lessons that we've seen so far, we have a teacher who brought in a guest speaker to talk about fire ecology, the importance of burning in grasslands and sort of outcomes of fire suppression and things of that nature. As part of our soil ARET, they talked about agriculture, but we also having prairie available to us in the grasslands, and GRL has some native prairie as well. The teachers had a lot of discussion about that environment in addition. And so the fire ecology piece is a really interesting segment that we hadn't talked about before, and she wove that in with the discussion of different ways that agriculture is done and different impacts that has on the environment. Related to that, quite a few of them are comparing agricultural practices and soil health. So they're looking at conventional till versus no-till. They're looking at grazing and fertilizer application, just a variety of different kinds of general practices. And the ability to do this comes in part because of all of the samples that they took during the ARET. They had soil samples from quite a number of fields under different experimental conditions, and they were able to bring this back to their classroom. So not only are they covering the content, the students are engaging with actual soil from actually different fields with different practices. And so they're getting this really authentic look about what is happening, even in places that they can't go investigate in person. Many of the teachers are comparing soil quality. And so not just how does soil health change, but let's look at the actual components of soil quality. What type of soil do we have? What's its pH like? How much, what's its nutrient content, things of that nature. And then also comparing that to native prairie that hasn't been managed. There was a pair of teachers from one school who did a really excellent mini unit looking at the relationship between soil health and biomass in cattle. And so students were investigating how soil health and soil quality contributes to the amount and the type of forage that can be grown, and then the health of cattle as a consequence of that. And so they did some research, and they had some guest speakers in, and so they incorporated the investigations that the teacher learned during the ARET, as well as the content that we discussed, and then made that agricultural connection to somebody fairly local to them. One of our schools, which is, I would have loved to do a talk just about them, they have a vertical 6th, 7th, and 8th sequence where the teachers have gotten together and worked out how their students are going to learn this content across all 3 years. And they focus all of their work around their local school. They're growing a butterfly garden and they're about to start a vegetable garden. And so they use those as sort of their focal point, and they bring in all of the science that they're teaching around that. And so in the 6th grade classroom, the students were collecting soil from the butterfly garden when they first planted it. And at the end of the semester, and they'll do it again at the end of the year, to evaluate how that growing has affected the soil and what changes they need to make in order to continue to grow this successfully. And then additionally, they're sampling from various points around the school to find soil that's going to be the most amenable to starting up their vegetable garden. And so the 6th, 7th, and 8th graders are all contributing to that, and everybody in the school benefits as well. There are several locations that are also developing community gardens. In LaFleur County, which is essentially all the way towards Arkansas, there's a pair of teachers there who have opened a community garden, and their students developed this by talking to local farmers and understanding what kind of crops they can grow in that part of Oklahoma. They learned about growing zones, they learned about seed startup, and they sort of went through the entire process of growing in working to build their community garden and have it be successful. And then we have another teacher who their school is abutted with a neighbor's farm. And so they have soybean fields during part of the year. I believe he grows corn at various times. And so they built a partnership with that farmer and his family so that they're allowed to go and sample the soil and sample sort of the edge plants as well. And so they have a very direct connection to what's being grown in their backyard, essentially. Another thing that we do with the teachers, in addition to those surveys, is we interview them afterwards. So part of that is just to understand how did the workshop go for them, but part of that is to get more information than what the surveys can tell us. And so when we ask them these questions, what we see is that they're really reinforcing what the survey results say and doing so in a deeper way. And they talk about how much they've learned from this and the depth that they've learned, the content about soil science and microbes and chemical interactions and technology and how it's being used, essentially the high-tech ways you wouldn't expect soil to be analyzed, and that many of them didn't think that they were capable of learning science at that level, which is really unfortunate. But they feel very confident walking out of the ARET. And as I mentioned before, since some of these teachers are the teacher, they find that this teacher collaboration and the mentorship that they get from working with Breck really, really, in many cases, that's the thing that they talk about as being the most valuable, just this opportunity to share ideas and to get some guidance for how to make what they're doing better in terms of what information they're bringing to the students and how they're asking students to engage with it. And that engagement is another thing they talk about. Their students are investing more in the work that they're doing, and not just in these ARET lessons, but other lessons that they take the practices and some of this content that they learned and incorporate it into their everyday sort of instruction. And the students are asking deeper questions. They are taking the content farther than the teacher necessarily planned. One of my favorite and surprisingly frequent things to hear is that students that typically perform poorly or students with special education needs are some of the most successful students engaging with these lessons because they're done in a way that give those students non-traditional opportunities to reflect their knowledge and also to engage with the content. And so that really bolsters teachers' confidence and students' confidence further that they're capable of doing this, that the work that they put into this is valuable, and they walk away with a greater sense of satisfaction and a greater understanding. And in the communities where students have connections to agriculture, whether it's a family farm or their grandparents, aunt, uncle, whomever, by bringing this local agriculture into the science classroom, teachers have been able to leverage their own students' background to be leaders in the classroom. And if you haven't engaged with middle or high school students recently, they really love to be the person who knows more than everybody else. And so this ability to let them be the person and be the expert, have the most knowledge in the classroom, really improves classroom culture in addition to deepening this connection and understanding with the science. One of our major components that comes from this grant and is associated with this grant is the lessons that the teachers write. And the really exceptional ones that are well written and are going to be able to be applied across multiple classrooms, we polish them up. We sometimes re-vet them in classrooms again if they've had significant changes made. And when all is said and done, we publish them on K20's Learn website. Our website hosts, lessons from all content areas and a lot of grade levels and some instructional strategies. And it's really highly trafficked. So from 2015 to 2018, we had 265,000 page views on the lessons alone across the entire site, not just our grazing cap lessons. But we have visitors from 128 countries and from all 50 states, which is really exciting because it means that the impact that these ARET experiences are having goes beyond Oklahoma, and it's translatable to K12 classrooms across the United States. And we might expect this just because, you know, the center of the United States has such an intense agriculture concentration, but things are being grown and agriculture relates across the United States in various pockets, and so and internationally. And so it's really nice to see and really heartening to see that this small group of teachers are developing resources that are meaningful and impactful and are helping bring agricultural education into regular science classes at a variety of levels. And so that's probably the biggest long-term impact that this project has had on the K12 education community. I'd like to highlight one lesson in particular because it was 2 years in the making and went through, I believe, 3 separate classrooms before it was finally published. So we have a lesson posted that is called Drought and the Dust Bowl, and it is it's something that everybody who's worked on is really proud of. It started from an ARET 2.5 years ago. A teacher who is in an science and arts school developed this as sort of an overview for her entire year. And so she centered it on the Dust Bowl and talking about the environmental impacts of that, but then branching out to the agriculture that was associated with it and the social factors that were associated. So how were people impacted by this in their daily lives? They looked at media from the historical media to see how the Dust Bowl was understood by people outside of it. And they looked at culture and art from that same period. And so she integrated all of these things, all centering initially on the idea of soil science and agriculture. And so we took that lesson, and instead of making it a broad overview, we really focused in on that environmental impacts piece, but we kept everything else as part of it. And so what the lesson turned into is an investigation of all of the factors that contributed to the Dust Bowl, including using art and media as scientific evidence for what was happening. So students analyzed Woody Guthrie lyrics, they analyzed literature and nonfiction accounts of Dust Bowl experiences, and they look for descriptions of the environment and compare that to what the actual scientific data looks like. And so they get this very rich experience that's driven by a scientific investigation and an arts investigation, and really seeing how science and culture are heavily embedded with one another. And it also, for Oklahoma, gave the students a deeper connection to their own history. Some of them have family members that this connects back to. Some of them, as part of this lesson, ended up learning things about their family that they didn't know. And it was just a really rich investigation. Since then, there's at least 3 additional classrooms in the state, I believe in Oklahoma City, who have used this lesson and intend to use it again. And it's one that I hope gets a lot of broader attention. 1, because we feel really good about how it turned out, but 2, that ability to bring agriculture and culture in general into the classroom is such a valuable piece for students outside of agricultural or rural communities who don't really get to see that. So that where we're going from here, we have another soil ARET in 2019. Based on teacher feedback, we think we might take this more in the direction of soil microbiology, still focused on the agriculture and native prairie, but maybe a little less on the general overview and a little deeper into some of the more complex content. And part of this too is that these teachers, as we get further along and more teachers have this professional development, begin developing research-based practices and bringing ag into the classroom, we're able to go deeper with them. We don't have to stick at just the basics. And so we can provide richer experiences going forward with these teachers and taking them farther into the research and to greater depth. We will get more learn lessons out of that, generally at least 2. Sometimes as this previous year has developed for us, sometimes we have 3, 4, or 5 that are really excellent, and it just takes a little while to get them up and published. And looking at some of these results, we're really pushing to get some actual publications out of this outside of lessons. So in the academic community, looking at sort of this agricultural impact in general, but also looking at a couple of these teachers and highlighting the specific work that they're doing to get the information out there and serve as a model for either other professional development providers or other educators to see sort of the possibilities and the directions that they can take this in their own school sites and in their own districts and states.